Twee sent me an email asking about the JiTT. The question asked, can a right-skewed curve be approximately normal since the data is not symmetric to begin with? So when we did our example in class, when we were simulating, we used a uniform distribution, right? Everything was equally likely in the dice rolling example. But you see one of the options here is I can sample from a right-skewed distribution. So let's see what this looks like. So we have a very right-skewed distribution, so skewed in fact that the mode is actually at 0 and there is no tail at all on the left. As long as our sample size is large enough, the central limit theorem tells us that the distribution of sample means will be approximately normal. So if we only take a sample of size 2, you can see the mean of this is still skewed. Obviously, now you can see the mean looks like it moved over. The mode is a little bit closer to the mean, but we're still not all the way there. And now it's harder to get to 50 because you need two things of 50 to average to 50. But if we change this to say 20, if you do this once, you can see here's where all the 20 are. Most of them are in the left side where most of the data is. Our mean is the average of all of these, closer to our real mean. If we do this 1,000 times, you can see our distribution is looking pretty dang symmetric. And in fact, our rule of thumb later is that that sample size needs to be at least 30. And then you're guaranteed to have a symmetric curve. So that's the answer is yes, even if we start with something right skewed, the distribution of the means is going to be symmetric because on average, we would have expected them to match the mean of our original distribution, which happened to be 14 in this particular case. And you can see the mean of this distribution is also right around 14. So that's what we expected. And then there's not as much ability to go outside of that because, well, they're going to balance each other out. These really high values coming up every once in a while are going to balance out the fact that we have more values in the low side.